Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So good afternoon once again. My name is Stuart Tansley. I'm a Senior Research Program Manager in Microsoft Research Connections. And if that's my day job, what I've been doing at night for the past 6 months has been the Acting Product Manager for the Kinect for Windows SDK. And we're going to be talking to you this afternoon a lot more about this SDK, which I know you've heard so much about. I have a special guest with me today, Dr. Anoop Gupta, a distinguished scientist in Microsoft Research. One of the things that's really characterized the Kinect for Windows SDK, much like working for Microsoft Research in general, is that we really have some quality individuals in the team. And Anoop is previously a Stanford professor, technical assistant to Bill Gates, run a number of product groups, and without going through his whole resume, please let me introduce Anoop Gupta, who is also the executive sponsor for the Kinect for Windows SDK.
Thanks so much, Stuart. Thank you. So first of all, welcome to this session. I know there are many other interesting sessions that are going on simultaneously. So again, thank you and welcome for coming here. As Craig Mundy probably talked about this morning, as computing becomes ever more pervasive in the sense that there are more and more segments of society that are starting to use and benefit from the computational technology. And as more and more scenarios and situations where computation is becoming a part of our life, it becomes really important that we allow for more natural interactions, where it is not the user who's learning about the computer and how to manipulate it, where it is the computer which is understanding how the person, the human being, naturally acts. Where the technology becomes ever more sophisticated, but at the same time, the technology disappears into the background, allowing for more natural interactions. So that is what we are, in some sense, trying to achieve with Kinect. For decades, in some sense, the human beings themselves have been the eyes and the ears for computers, where we see on their behalf, we manipulate, we take the actions. With Kinect, what is very exciting to us is that it is a first big step where now the computer is getting pretty sophisticated, although a first step, eyes and ears of its own. And therefore it can act on our behalf. It can understand us in our natural way we behave, and can respond to that. And that is what has led to the excitement around Kinect since November 4th. As you know, it's on the Guinness records is the fastest selling consumer device that is there. So, all goodness. Now, what the Kinect SDK is about is our strong belief that it is not just the tens of millions of people, who are using it already in the gaming environment, but the possibilities are there to get to hundreds of millions of people who have PCs or in other environments, where such natural user interfaces interacting through gestures, through speech, and a variety of ways we can make a difference. So, as an example, one of the things that Microsoft Research does is we have TechFest, something we call TechFest every year. It happens in March. All of the researchers from all of our labs around the world put up a show internally for the rest of Microsoft, product groups and divisions, and we say, here is all of the cool stuff that we are doing and creating. And the interesting thing to observe this year was that almost 25% of the demos, and they span all variety of fields, were leveraging Kinect in one way or another. And of course, it's not just around what you do with gestures, waving, or speech, but it was a very large variety. So let me just give you a couple of examples to indicate the thing. So one area certainly was around telepresence. Okay, and in telepresence, you're trying to create an environment, so you're naturally there without actually being there, and you can interact as if you were there. So now a key problem is what you call mutual gaze. How do you get people in an environment? So if I know I'm looking at you, everybody else knows I'm looking at you, and how do you get a variable number of people together? And so the notion was that if you can have a real-time 3D model of a person, okay, that is built from one Kinect or multiple Kinects, then you can place virtual cameras at any number of angles, and if you're modeling the geometry and everything right, then it can be as if you're in a virtual environment truly interacting, and Kinect was being leveraged for that. If you look at displays, there's a lot of fondness for autostereoscopic, where you do 3D without having to wear goggles. So it turns out if you have columnar light coming out of a display, you can direct light to one eye, but you have to head track, track the head of the person to decide how to feed the light into. And so, people were showing demos of that. People were showing demos of, how do you look through a window, and again, tracking the head. And I know Craig sort of showed a lot of examples. So the whole point, in some sense, for the Kinect SDK for us is where we are today is simply the first steps into this journey of the amazing things that can be done when you start having such sensors available at very low cost and with the raw capabilities. Along with the Kinect Windows SDK, of course, there's the Robotics Development Studio. So, robotics, you're trying to build 3D world models in healthcare, in manufacturing, again, where you have dirty hands, in interactive displays. Many, many possibilities are there. Also, in particularly targeting the academic community, the goal for us and the researchers like yourself is not only what kinds of applications you build, but also a lot of fundamental and foundational research that needs to get done. To bring Kinect, to life and to market, MSR participated very deeply into the development of the technology. So you say, how do you take this very noisy depth pixel data and convert that into gestures and recognizing all body parts and the movements? Or in very noisy environments with high volumes of sound, how do you take a microphone array and do the appropriate beamforming, do the multi-channel echo cancellation, and help understand speech? So the Kinect SDK also makes all of that raw sensor data available so that a lot of fundamental and basic research can be done on top of what we are trying to do. So base thing, when the Kinect launched November 4th, it was a big question for us, how do we deliver the SDK? The product team so far had been just very, very busy in shipping and making sure they were shipping a great product. We jointly decided that Microsoft Research and our Xbox division participating together in the partnership should bring the SDK, particularly because Microsoft Research was very, very excited to get to our community of academics and researchers and students, and for teaching purposes and research purposes, make all of this functionality available. We've taken all of our research algorithms, we've taken a lot of our engineering effort, to build a product and to ship it. I mean, shipping a consumer product takes a huge amount of energy. So it is not a research demonstration where you say, hey, I did it under ideal lighting, this or that, or people who look like me, it just works. You have to make it work for short people, tall people and short people, people wearing funny clothes, people having dreadlocks, all of those situations, you've got to make sure that the human tracking works, the speech works in very noisy environments. So we've taken from our side and taken all of it, and we're delivering it in the Kinect SDK. But again, I want to emphasize at the same time, okay, this is the first step in the SDK. We look forward to all of you using it. We look forward to all of you providing us feedback on what is good, what do you see as the key gaps associated with it, and giving us feedback. And because we want to create the best SDK for all of you to develop on top of and do research. And I believe that collectively, with the amazing stuff that will come out of the community and what Microsoft can do with it, and we can usher in truly this era of natural user interfaces and interactions that we all feel pretty excited about. So with that, I just wanted to do the introduction. I want to hand it back to Stuart, who's been a key partner with me throughout as we have built and developed this SDK. We have many sessions planned for you. This is just the first session, which introduces the community and an overview of the SDK. There are some demos later this afternoon, at 4:30 that are there. There are 2 sessions we have, which are deep tutorials tomorrow that are there. We're taking our team members who actually wrote the code for the SDK and therefore understand it deeply. Being there, the general manager, Gavin Janke, will be there to present the tutorial sessions. So we are very excited, and thank you so much for coming. Stuart, all yours.
Thank you very much, Anoop. Appreciate it. So it is a great pleasure. I certainly don't expect a whole bunch of Christmas cards and thank you notes, but really this SDK is for you. We realize that NUI, Natural User Interface, is too big a field for us just to try and innovate on alone. We're certainly going to try and do that. We see some of that in the presentation this morning from Craig and some of the things that Anoop has spoken to. But this is also a ecosystem, a community opportunity for us all to work in NUI. And we hope that our contribution through this SDK and other technologies that we'll release in the coming months and years will help to raise all boats in this field and help the field progress further more quickly. I wanted to, as Anoop said, there's a number of sessions on Kinect. I'm sure the numbers will peter out gradually as you get tired of Kinect, but we're very proud of Kinect, and we're amazed by the enthusiasm that we see. So we thought we should respond with a very thorough number of presentations. This one today is scene setting, introduction, background, and also an opportunity for you to give us direct feedback based on your thoughts today, what you already know, maybe what you've already experienced with the SDK. Our sessions in Faculty Summit in general this year are a little different. Those of you that have been to Faculty Summit in previous years will remark upon the 90-minute sessions, and they think, oh my God, it's going to be 90 slides in every session now. So we're really trying not to do that in this session or the other SDK sessions. This should be a more relaxed pace. There should be room for discussion, interaction. I'm really looking for a two-way dialogue in this session, as I hope you will find in the other Kinect-related sessions too, and maybe also my colleagues in some of the other sessions. But we're really trying not to nail you with a whole bunch of just slideware. That having been said, I do have some slides. And I'll proceed with my deck to give you a little bit of background, where we've come from and where we think we're going, and what we've achieved in just the past month. Project Natal was the original code word that some of you may remember that Kinect was called, and it was announced at a conference called E3, a gaming conference. The whole principle, as Craig touched on this morning, was the Xbox team were really looking to expand the popularity of Xbox. They're a business. They're a commercial part of Microsoft. Unlike Microsoft Research, perhaps we get to have a little bit more fun elsewhere. But Xbox is there to drive numbers and get consumers to buy games, to buy Xboxes. And one of the big barriers that they were seeing was that the controller, the hand controller, crossed out there in my happy logo, is that this was a barrier to much broader adoption. So maybe there's some nerds in the room, maybe there's a few geeks in the room, and maybe we don't mind so much this hand controller. I thought that the analogy this morning was good, that using a hand controller is a bit like learning to play a musical instrument. But if you could just go into karaoke mode and use your natural expression, that would seem to expand the opportunities for entertainment in the living room, which is what Kinect is all about. So to get this concept from Project Natal to Kinect has been quite the journey and quite the accelerated journey. This is about a 3.5-year journey, and that is a representative of a pretty fast pace from what was bleeding edge. In fact, you could not achieve what you could do with Natal today with research just 3 or 4 years ago. That's part of the breakthroughs here. It's not just a cool product, it's not just entertaining and fun to watch people do these crazy maneuvers, but this is actually a fundamental technological breakthrough. And we in computing are often seeing these things every few years, but it's very cool to see this so accessible to so many people. So Project Natal, does anybody know Natal? I mean, I'm going to reveal it immediately here on my slide. So thank you, Wikipedia, for helping me understand where Natal is. At the top right-hand corner of Brazil. The Brazilian city Natal the name is relating to birth, and Alex Kipman, who's really the father of Kinect. There are many people involved in Kinect, but Alex is one of the guys that conceptualized this thing from the beginning. He was really looking for the birth of a next generation of home entertainment, no more, no less. And so his hometown of Natal, he's Brazilian, seemed like a very neat match. Hence the code word Natal. The device that we know as Natal or now Kinect, that black bar, that strange-looking device, maybe not so strange now as it's become so pervasive. That is just the sensor unit. But of course, the sensor just provides eyes and ears. You need a brain, just like humans, animals, beasts of all kind. You need a brain to get that sensor data into a usable semantic format to understand meaning. Taking that raw data from the sensor, it's really just a bunch of noise. There's a nice quote from Alex Kipman here. And that's what our software does. The advanced software, both in the SDK and on the Xbox, these are largely the same. We've done a porting from the code base on Xbox. What you get in the SDK today is what's running in the Xbox, essentially. And that's what our software does, is find that signal, find that meaning, find the semantics in that otherwise just noise, a bunch of noisy signals, noisy data. Moving from Natal to Kinect, you know that this took decades of research in computer vision. I'm going to be talking about audio too today. We don't want to forget audio, but of course the vision is very much front and center. So back in September 2008, when Natal had already been conceptualized by Alex and others, they needed some help. They had a prototype, and they really impressed the researchers in Microsoft Research, who are some of the best vision researchers in the world. They were amazed how far Xbox had got. They'd really got to the bleeding edge of the capabilities of skeletal tracking, of human body tracking at that point. But it wasn't quite what they needed to make a home entertainment system actually work in practice. So some magic happened between September 2008 and when it was first announced in June 1st, 2009 at the E3 conference, the computer gaming conference. And then some more magic happened in refining those early prototypes for the launch on November 4th, 2010, just a few months ago. That's now available in numerous places around the world. I really ought to get a much longer list. It's quite a long list of countries now. And the last figure I saw was that 10 million had been sold as of March 9th. Microsoft's financial figures, the quarterly figures are announced this week. Maybe we'll get an update. I'm certainly be looking to see if we get an update on the Kinect figures. And this makes it the Guinness World Record of fastest selling consumer electronics device of all time. And that's simply amazing with so many cool electronic devices, consumer devices around today. We know all the famous names. I won't mention any letters. But to be the fastest selling consumer electronics device, pretty amazing. We were proud. Yes, we wanted to be successful. But I think the phenomenon that is Kinect has been universally amazing. We're very, very proud and pleased. The problem that Kinect is solving, I don't want to dumb this down too much, but for those that are not into computer vision, I'm sure there's a few of you in the room. You're really trying to find the people in the scene while ignoring the background, a classic background separation problem. What is person? What is background? What is plant? What is lounge chair? What is dog? You need to, though, find the limbs. You need to break down the human skeleton into the limbs and joints. You need to determine which person is which, because it was key for Xbox that you have more than one player in the scene. Yes, you can have some fun watching a single player or enjoy it as a single person playing an Xbox. But it's twice as fun if you can have two, and if you can rotate the players and track up to 6 players, as we can in Xbox and the SDK, then it's just a much more lively, much more entertaining scenario. So you need to track their gestures, not just find out where their static positions are, but you need to track what's happening, what the dynamics are. And then map those gestures to meaning and commands, so that now you're not just waving your arms kind of like a crazy person in front of the computer and in front of your TV at home, but now actually getting some meaning. You're commanding the system to actually do something. Meanwhile, Xbox also were keen to have facial recognition, to know not just it was like player 1, player 2, but now I could assign a name to that person. I could assign perhaps an avatar to that person. And also recognize speech. Let's not forget speech and audio today. I will be mentioning that a number of times. Meanwhile, you also got to play the game, right? On Xbox, the thing in front of you is trying to run a probably really high-end game like Halo or Crysis or any of the other games on Xbox. The software, the system, needs to be running all of the AI, all of the graphics on that machine. So I can't be solving all these problems with using 100% of the CPU, which just a few years ago it would have taken, and more. So this is software magic. It's been very trendy to call technology, especially in the IT field, our field, magic. Well, I do lay a claim that this sounds like magic to me, and I've been in AI a number of years, and I've been in software a number of years. So this is definitely one of the closest things to magic I've seen. It's machine learning. Contemporary pervasive technology, of course. I'm going to give you a lot more detail, so those of you that already want to jump ahead, just bear with me. What the machine learning is effectively doing is evaluating trillions of the possible body configurations of 32 skeletal segments. It's doing this every video frame. In America, that is 30 times a second. And it's doing that on less than 10% of the CPU, because the rest of the CPU is running the game or the other entertainment software that's on the Xbox. Or if it's on the PC, now in the SDK, it's running your app. Behind the magic is this decades of computer vision research between industry and academia and our own efforts at Microsoft Research and Xbox. We work, as you know, most of you know, we work in partnership with academia all the time in Microsoft Research. So this represents really the culmination of the entire field. And we're proud to sit on that achievements of the field. We've contributed ourselves, and I'm going to say a little bit more about that in a second. The state of the art in human body tracking in 2007, when Xbox were first conceptualizing this, is you had the ability to track a fairly wide range of motion for a single model human being, but you couldn't do it for all shapes and sizes of human being. It didn't generalize. And you also couldn't do it in real time. You could do this in a batch processing job. Maybe it took overnight, maybe it took a week. I forget the details now. But you certainly could not do it in real time. Xbox, calling up MSR in 2008, said, hey, MSR, can you help? We've got this prototype. It kind of works. We think it's cool, but you know, we're far away from shipping a consumer product. So they wanted all motions for all populations, because they want to sell Xbox to everybody. They want all agilities. They want kids. They want people that are not fully able. They want short people, fat people, tall people as big as your head. You know, the lot of it. They want all agilities. They need that in 10 times real time because it's only 10% of the CPU. And they want it for multiple people because they want to rotate the players in the scene. They don't want to just do it for the single player in front of the TV. They did offer one thing. Thank you, Xbox. They did have a low-cost 3D depth camera, which is definitely a key component. Having that low-cost depth camera is a breakthrough technology, but of course you need all the software as well to make it work. The vision algorithm if you haven't heard, I'm proud to announce that at CVPR, one of the vision conferences, last held in Colorado last month, this won Best Paper. It's the Kinect paper. It's the Kinect Vision paper. So real-time human pose recognition in parts from a single depth image. Go check it out. This paper is pretty detailed. I think Xbox got pretty nervous about how much details were revealed in this paper. And I'm pretty sure we're not going to say anything more than what's in this paper. I won't click on these links. You can go check this out after the event, or go surf the net now. This paper is detailed. There's also a supplementary paper which also gets into even more detail, and a video as well. So those of you that do want to study the algorithm, we give a fair amount of detail in this paper. It's a fun read. The vision algorithm, I thought I'd summarize for you. Since I'm here at Microsoft Research, I'm meant to understand this stuff. So what you're trying to do is quickly and accurately predict the 3D positions of body joints. That's the essential problem here. You're trying to do this from a single depth image because it's doing it frame by frame. We don't have any temporal information. Yes, I'm interested in gestures at another level, but that's not how the vision algorithm works. It just looks at it single frame by frame. And the magic component, the insight that happened at Microsoft Research Cambridge in England, is that this took an object recognition approach. This was something that had been done for years in Microsoft Research. In fact, I'd presented on this work a number of years ago, not realizing myself about how it could map ultimately to a more dynamic situation, to a live video feed. So if you can segment a single picture with now some 3D information, because you've got depth in there as well as the 2D space, if I can address this as a classification problem and address the problem as a per pixel classification problem, where does each pixel fit? What's the probability of a pixel fitting in one of these body parts? I can throw that at a machine learning algorithm, throw it at a bunch of expertise from really high-end vision researchers, and I can now get a powerful algorithm which in practice works and has been shipped as a consumer electronics product, which we've now made available as an API in an SDK that all of you can use today for free. The classification problem goes into a bit more detail on this slide. I don't want to go into every line here. You can read it out as well as I can. But as one of the key points in the paper here is that this system runs at 200 frames per second in practice. So it's much faster than what Xbox actually needs. We are a little slower on the PC today. It's the first version. We don't have the benefit of a dedicated GPU. We've had to generalize that. So in our code porting from the Xbox to the PC, we are not quite as performant as this in the SDK today. But it certainly gives you, there's plenty of headroom for optimization over time. And we're very interested in doing that. The evaluation of this work really shows high accuracy. It's working well. It's being used by millions of consumers around the world today, and a number of programmers as well now. And it's really representing the state of the art in accuracy in comparison with similar work and related work. It's got better generalization. It's a very cool piece of technology and a deserved winner of the Best Paper Award, I think. In practice, let me jump up a little bit more abstractly. How to make this work beyond the core algorithm is we had to collect thousands of hours of video of real people, real human beings doing real crazy stuff in their living rooms. This generated billions of images. We used a Hollywood motion capture technology. We went around the world because you can't distrust one demographic in one locale to be general enough. And so this was an amazing data collection exercise. And all of that data needed to be stored, processed, just like Craig was talking about at the very first part of his presentation today. We applied state-of-the-art object recognition research, also the semantic segmentation research that was done in parallel with that. We built a very large training set. We classified each pixel's probability of being in any of the 32 body segments. and then clustered those to also help the algorithm. Because what we're trying to do is identify not each pixel ultimately, we're trying to identify the body segment, so clustering is appropriate. We had millions of training images, and it ended up in millions of classifier parameters. This was very hard to parallelize. It required a new algorithm for distributed decision tree training. Again, years of work in Microsoft Research and elsewhere has gone behind that. And we used our own Dryad Link technology, which is a large-scale distributed cluster computing, again, an algorithm and technology that you have access to as well. You can just download this from Microsoft Research. And it was a major use of this technology at scale and in a production environment. So don't forget the audio, I said, and I will not. We get carried away with the vision. It's all very gesture, and we forget how amazing the audio is in this device too. So there's 4 microphones in the Kinect device. It's an array, and because it's available in millions of units for a very low cost, what we've now provided to the community is a standard microphone array, something that the community's been looking for a long time at a low cost. Here we are, we have it. We're also giving all the software that processes things like echo cancellation, like beamforming, and the other cool things that you can do with a microphone array. There's a whole 1-hour presentation on this, which I'm not even going to attempt to get into. But Ivan Tashev, who is, as the very last line says here, the creator of most of the audio algorithms in the Kinect pipeline, has already done this awesome talk at the Mix conference that happened in April. So check this out. It's got lots of cool color 3D graphs. It's got lots of math in it, and Ivan's a very cool guy. Check out that presentation if you are interested in diving further into the audio processing. So we've published pretty well, I think, on Kinect technology for exactly this audience. Please go check out the papers yourself. Also go check out, get your students to check out these papers and help them contribute to this field and go further, take this work further. We've got the video papers out there, and we've got the audio out there. Getting back to the SDK. There was a really nice article. I put in vertical text there for not ease of use on the screen, but after the event. Wired magazine for the July issue presented a nice version of the story that is behind the Kinect for Windows SDK. People like my friend and ex-colleague Johnny Lee are mentioned in there with his creative solutions to getting a Kinect for Windows SDK out. There are many conversations that happened, and there's a much richer story than what any one article can describe in getting out this amazing technology to the world and this SDK to empower all the developers for this work. My own work started about a year ago in pretty much this very room. Actually, it was next door in Kodiak, and there were questions in that room at the last faculty summit about, hey, Stuart, hey, Microsoft, when can you get us a Kinect? When can you release the Kinect SDK? Are you working on a Kinect SDK? So I took that as a call to action, a personal one and also an official one very quickly to really help get a Kinect for Windows SDK out. My story is just one thread through all this. There are many other people involved. Anoop and I have enjoyed our partnership, but we're part of a team of tens of people, including the partnership between Xbox and Microsoft Research. So many people contributed to this SDK, and I'm proud to be a small part of it. As the retail launch was approaching, we got pretty busy as a company just shipping that SDK. It is hard, as Anoop highlighted, to ship a consumer electronics product for millions of units. Yes, as researchers, we think this might be easier than it looks because we're used to producing demos which work most of the time and at least once anyway. It works. Maybe we can get a YouTube video out. But shipping a unit that works in living rooms, that's reliable, it's a whole different ballgame. But around Christmas, we really started to get some momentum behind the SDK effort, and by February 21st, we made our first big public announcement. And it was very cool because Don Matrick, the president of the Xbox division, IEB, And Craig Mundy, who you heard this morning present, essentially the most senior technical leader in Microsoft today. These two top people in Microsoft, these top executives, made an announcement about the Kinect SDK. And they said, we commit to the field that this will be available in spring 2011. It would be for non-commercial use. We would focus on getting this out for researchers, for academics, for enthusiasts first. We know that there would be commercial interest. Boy, do we know. We get so many emails, so much interest. We know there's a big commercial potential for this work beyond the entertainment sector. But let's get this out to the people that can really innovate more broadly on this technology. And let's make it free. Let's not create any business model here beyond making this available to the widest number of people possible, the widest number of innovators possible, people like you. We then scurried away, worked hard, and next spoke to everybody in April, where we announced our website. And eventually, come June 16th, we finally launched at the researchmicrosoft.com, that's the RMC, Kinect SDK website. So you may remember, this is what we put up there for months, and the clock was ticking. I always wanted a countdown timer. I really wanted a countdown timer, but the web team said, no, you don't want to do that, Stuart. But we felt the countdown timer internally. And spring was ticking away, and there were lots of questions about, well, when really is the end of spring? But we were very confident, those of us that are astronomers, about when the end of spring is. And so June 16th, definitely within spring. And so here's our new website. We're very pleased with the website. We're very pleased how we've managed to get this out in time. It's been busy. It took a lot of work. And the team has been simply amazing. Very, very high quality team. And in partnership, not just Microsoft researchers, not just the engineering team in Microsoft Research, the web team in Microsoft Research, marketing, PR in Microsoft Research, but also our colleagues in Xbox too. What's actually in this SDK? Have we mentioned that today? I forget now whether we've gone into any details. We're sort of talking a lot about the SDK, but what's in it? So there's the raw sensor streams that's accessing the audio, that's accessing the vision, the RGB video, the regular kind of webcam video, and then the depth stream. Everybody wants to get the depth data because that's one of the rare pieces within the sensor device. So you can get access to that using an SDK. We have a full API for those raw sensor streams. Also, all that software, all that machine learning, all the AI that does the skeletal tracking in the Xbox today, you too can get access to that on your Windows PC now at the full fidelity essentially of the Xbox now on Windows. The advanced audio capabilities, not just the raw audio, but you can get to things like the echo cancellation, things like the beamforming. You can also throw this into the speech engine available on Windows and get speech recognition. We've got a bunch of sample code and documentation. We've got over 100 pages of documentation, and it's really high quality. This is really product quality documentation, as is we like to think we approach product quality in the overall SDK. We haven't promised product quality, but it's been a very high quality release. We will be refining this release over time, continuing to improve the last issues in the SDK that we're seeing now. It's being used by so many people. And one of the things that we must thank you for as a requirement, a line item here, is easy installation. Boy, have I been beaten up over the years I've been involved in presentations like this, in communities like this, about how our software is often not easy to install. Our multi-gigabyte installs, people in India struggling over low bandwidth links, downloading a lot of code. It's difficult. We appreciate that. So we get the message, and one of the things we really try to pay attention to was to make this an easy install. We know we can make it even easier. Watch this space. We are going to make it even easier. It's designed for non-commercial use, as I've said. A commercial version we have committed to being available later. Don't ask me when, because I don't know, frankly. I'm working with a team that is also trying to figure that out. It will come in time. We want to get it out there as soon as possible. There is so much to do for a commercial version beyond what you see, what we can do in a research context. It's just a lot more work, and a lot of it is grungy work about it's process orientated, it's regulatory orientated. It's just a lot of things that are not technical. This works on Windows 7. Please don't ask me any questions about Windows XP. It works on Windows 7, period. We like Windows 7, you should too. C++, C#, Visual Basic all work. We've not seen anybody explore it in other languages. I bet you it might work, but we just don't support that. Do try it out and tell us how you get on. And it works in Visual Studio 2010. There are other resources. One of our key partners that I've not mentioned yet today has been Channel 9, and in the Developer Evangelist division that help Microsoft communicate to a much broader community of developers than even in people in this room. All of our commercial developers, all of our hobbyist developers. Channel 9 is an awesome website with a number of cool resources on. They do things like events, webcasts. They have an area called Coding for Fun, which is full of neat little projects that really fire the imagination on what you can do with some of our code, now including the Kinect for Windows SDK. They helped us in the launch, and I'll say a little bit more about launch because we had a fun time at launch in a second. The videos from the launch webcast, there's Anoop actually at the bottom left there, talking to Jeff Sandquist, the head of Channel 9 and the folks that we work with there. There's a number of webcasts, and I mention this here to you today because maybe you gals and guys don't have time to go through all this material, but your students sure do. So do send your students to this website as well as the researchmicrosoft.com Kinect SDK website. This has got a lot of cool resources on it. Not least Coding for Fun, the sub-part of this is really our project gallery. So we're building up gradually a whole bunch of very creative examples of how the SDK is being used by a very diverse number of people. And I'd really love some of your projects to be shown on this website at some point. I'd also like to see you produce research papers at CVPR and all the other cool conferences as well. But if you have a fun project, if you have a cute project, this is a great place to put it. And if you have one of those, please let me know or mail these people directly. It's a really nice place to go, and they've got a lot of traffic, so you'll get seen by a lot of eyeballs. So be part of the movement. Come and join us. If you haven't already, get yourself a Kinect. They're not hard to get hold of. Available in any retail store. Only $150. Easy to get hold of. Do get the standalone version. Don't buy the one that comes with an Xbox. Yes, I want you to get an Xbox as well, but the one that comes bundled with an Xbox doesn't come with a magic cable. So get the standalone one. It just makes your life a little bit easier. Otherwise, you have to get into other methods to get the cable. What I want to do now is just pause for a moment for any questions or feedback, and then go on to a little bit more about the community, what we've done over the past month, what happened at CodeCamp, and where we're going to go with this. So let me just open it up and pause for any questions. So we've got mic runners if there are. Yeah, there's a question at the back.
Hi. So this morning, Craig Mundy talked about the avatar and facial recognition stuff. Is the facial recognition stuff in the SDK at this point?
It is not today. We would love to get that technology out to a wider community. We don't have a commitment to it today that I know of anyway, but I'm very keen to have those conversations to try and get that technology available. So no commitment today, but it's clearly a very nice way forward. Any other questions? Yes, at the back.
Is there a plan to have
Microphone.
Is there a plan to have a redistributable version of the DLLs so that it'll be easier to bundle the Kinect stuff in with something that you ship to other people?
Yes, great question. So a redistributable version. So for the research version, the non-commercial version, the academic version that we've made available today, We felt we didn't need to do that for the current time frame, knowing that a commercial release most likely would have to make that an inevitability. So we see that as something that is required for a future commercial release, but not an absolute necessity. It may be nice to have, but it wasn't a priority for us for this current release. Now, partly there's going to be a gap here. So, with future commercial release, current release. Current release doesn't have that. Is the gap wide enough that we need to think about that as an interim solution? I don't have an answer for you today. Obviously, we'll keep looking at that. We'd love your feedback on the actual scenarios, the uses that you're seeing that might drive that requirement. So keep us posted on that feedback. But at the moment, we're not intending to do that for the non-commercial version. Another question? Yes?
So I won't use Windows XP, but
there's always one.
Okay. But I mean, just so that this question maybe, coming up later, I thought you would clear the air on that. So, what is the general plan for making it available to even a wider audience, or is it just going to be let the hackers in the community figure it out and work backwards? I'm not using the other word, the Linux word, things like that. But I mean, you might as well clear the air there.
So I think I get the general drift, but I'm on dangerous territory if I don't get your question right. So could you just be a bit more specific?
Oh, okay. All right. So basically, I mean, platforms, OSs, other than Windows 7.
Right.
Okay. So, I mean, is there any general, since this is an academic kind of...
Yeah. No. So I think we will have a little bit more clarification to talk about over our license and how people have interpreted the license to date. And we do know that there are some challenging ways to interpret the current license agreement and the questions, the FAQ that we've released with this SDK to try and explain what our intent here is. So you will see further refinement to try and clarify what we're really trying to get at here. But at the end of the day, Microsoft is about Windows. It's about interop with other platforms. But we're not here to drive direct support for other platforms. So you'll see Windows as our home plate, as our home base for our support. We will try and clarify what it means to use our technology on other platforms. But ultimately, you do get into some unfortunately legal areas, and it will be between you and your counsel as to really interpret this particular situations. Right now, though, we're interested in seeing this technology used by a very wide number of people. There's an awful lot of people that use Windows. I know it's very much more heterogeneous environment in the academic world. I totally get that. I know that we make every effort to make Windows available at essentially no cost to academics, whether faculty or students. We try really hard with that. So I don't see that as a particularly big barrier today. Were there any other questions before I move on to the community? One more. Yes, let's make this the last one of this segment.
We've been curious about the possibility of adding further sensors, principally an infrared sensor, and I wondered whether you had been thinking about the same thing.
So literally, I guess I could say yes, but it's really just thinking about such things. I think that one of the things that's pretty obvious to me as a research person is that retail unit in its shiny black plastic unit, it's a consumer electronics device, and as a research tool, we really could do with something, all of us here as researchers, have something that's just a little bit more Lego brick-like, more open as far as flexibility of form factor and so on. We don't have any plans to announce today on that. and I don't know of any specific intent towards that direction. But we are thinking all the time about how we can refine this technology, both the SDK offering and the hardware offering. So we appreciate your feedback. Please channel that feedback either through our forums. The forums are on our website, or directly to me. Probably Anoop's got too much email, so don't send me to Anoop. Send it to me and I'll send it to Anoop. But please tell us your feedback, the sort of things you'd like to do. We're listening. We're listening to what people want to do. Okay, let me move on to the next segment. This is a short segment to wrap up the session. You're probably fed up with that animation by now as well. The community update. So we launched in a rather interesting way. We had a CodeCamp. It was a 24-hour event the day and night before the launch on the 16th of June. And there's a little snapshot of the code campers there. It was amazing that some of these people had never developed on Windows before, and yet they produced some cool demos. And I'll say a little bit more about what they did in a second. The first month, this is what we've done. We've done trainings at the University of Washington here for the local area. We've done a big presentation in the UK. At the Reading headquarters of Microsoft in Berkshire in England. There's been a developer presentation in France. I presented remotely from my living room to Australia. We were trying to get Avatar Connect working, but we got hamstrung by, of all things, firewall ports. Would you believe it? So the Avatar Connect worked, but the firewall ports we got blocked by. But we did a remote presentation, and then I think it was a day or two. Is John Warren here? Yeah, it was a day or two, John? Two-day workshop on Kinect and other cool programming in Australia. I think that's probably the biggest event that's happened so far. There's about 200 people involved. Yeah, 200 developers involved in Sydney, Australia. And then in New York, I was just in New York enjoying the warm weather there, but also enjoying Imagine Cup, which is the grand final of our student competition. I think there's over 300,000 undergraduates register for this competition every year. And the finals just happened last week. And we did, I think it was the most popular training session. It was oversubscribed. I think we had room for 70 and then 80 in the room, and 93 students showed up. Well, they really could have been enjoying partying in New York. And or at least getting on with the competition, they came and learned about the Kinect SDK. So that was a very cool event. So we are making some efforts to kind of get the word out about the Kinect SDK. We know a lot of people have heard about it, but I'd also like your feedback on the sorts of things that we could do and the sorts of things that would be useful in your schools. So think about that feedback, so I'm going to ask you more about that in a second. I do recommend that you, if you don't have time, send your students to look at the CodeCamp Showcase. We had 36 essentially strangers that didn't know each other largely from all of these universities and these businesses. And we brought them together as developers, saying, you know, bring your best developers, bring your kind of youthful, enthusiast developers that don't mind not getting any sleep, and come and work with us for 24 hours, learn the SDK, and see what you can produce. And the demos that they produced are all on these 3 segments of videos, which you can go and click on after this presentation. There's also a really neat slideshow. I'll be showing that in DemoFest later. So check that out. Some things you might have seen before. The lightsaber. This was a dual-handled lightsaber. The AR drone, controlled by gestures and speech. Lots of cool demos. That one up there with the hemisphere, the semicircle rather, is a Kinect a music conductor. I think that's Josh Blake from Open Kinect worked with a team that did that. Very cool demos. So do check those out. Next steps. So we think some contests might be a good idea. Imagine Cup is in Australia next year. And really, an undergraduate contest seems a no-brainer to have as part of Imagine Cup, and those discussions are happening today. It's essentially going to happen. I do think there's room for a couple of other contest types, though. And there's a research contest opportunity and an open contest opportunity. An open competition allows you to enter as well, but also all the hobbyists and enthusiasts, and even some commercial developers that might want to enter a contest, really to showcase innovation around NUI, around Kinect, using the sensors, using the skeletal tracking, using the raw data streams, all of the above, and with other sensors perhaps. So these contests are a little bit more than ideas today. We've made some progress, but one of the things I wanted to ask your feedback on today while we have each other is on the research contest, because we're primarily researchers in this room. And I'd love to know what your thoughts are on what would make a good approach to a research contest that you would be interested in participating in, that your grad students would be interested in participating in, that would make a difference to this area and help accelerate the field overall. So think about that for a minute, and then I'll ask you some questions at the end. There's also some research workshops that we'd like to do. But I view this as a little bit, let's do this later, and let's also do this as part of the regular cadence of research conferences and workshops that happen anyway. So we might find it's useful to have a Kinect-related workshop in some other standard research conference. I have a big interest in robotics, for example, and I see a few robotics friends in the room. And there's definitely room for activities, some of which have already been organized by other groups evaluating Kinect and experimenting with Kinect. But for us, we want to convene things a little later. We wanted to see some more work done first. One of the things I'm really trying to avoid is, well, I could put up a bunch of cutesy demos, and I'm probably going to show you some at the demo fest shortly. There's an easy to satisfy quick gratification that happens with Kinect when it's very neat to put up something cutesy and nice. I mean, I do that too. I enjoy that too. But this is a piece of technology that we think has got some serious implications for our field. And so we really want to encourage, both with this presentation today and our dialogue in general, is to think about this deeply and think about what are the hard questions, what are the more fundamental questions, what are the more profound questions around the application of Kinect technology and the potential of Kinect technology. Because we want to work with those folks that are thinking more deeply and thinking about this in a more profound way about how this could change how we all interact with computers more fundamentally. So let's do some more work first, and we will look for opportunities in the coming months and years to do some more hardcore research workshops around this technology. Kinect SDK at Faculty Summit. So you are here in the community update and next steps, and I'll be asking you my questions in a second. There is the demo fest coming up shortly thereafter. I'm not actually going to show you a whole bunch of demos, although we can talk about what you'd like to see. But we will have some demos, and we will have the system up. If you've not used Kinect yet, strange it may seem, there might be a few that have not used Kinect. We'll give you a shot at trying it. We even have 2 demo stations. There's the worldwide telescope being controlled by Kinect, which is a very, very neat demo that's been shown also in the room. Tomorrow we have the 2 tutorials. As Anoop mentioned, Gavin Janke and his cohorts, his developers, are coming along to present this, and it's a really rare privilege. It's one of the cool things that you get for coming to Faculty Summit, in some cases a long way for you. But you get to meet the real people that developed the Kinect for Windows SDK. Not so much researchers; these are the developers. These are the real people that developed the SDK, did the porting of the Xbox code, and I'm really pleased to have encouraged them to come along and for them to try and teach you the Kinect SDK if you'd like that. There's some other NUI work. I have broader responsibilities in my copious spare time to address the NUI field. In Microsoft Research Connections, Natural User Interface. And my colleague, Kristin Toll, is chairing a panel tomorrow about NUI, the road ahead, with a number of distinguished professors. So do check that out if you're interested in the broader implications of NUI. And then last but not least, we get back to vision again. don't forget the audio, but we get back to vision and have one of our most esteemed vision researchers and graphics researchers, Rick Salisky, doing a closing plenary tomorrow. So I'll put up this again and get back to my question. So I'm open to questions from you. We've got a number of minutes left. So again, it's a relaxed environment, don't feel rushed. But I have some questions for you, and I've really mentioned them. So I mentioned contests. And I'd love your feedback and thoughts about what would make sense for a research contest, both in the NUI field, maybe in the more human body tracking, human motion tracking field, the more using the raw sensor data. Maybe it's adjunct sensors to enhance the capabilities of the system. What would be useful as a mechanism to use this? Are there existing research contests that interest and intrigue you that maybe even you're participating in today? That you would suggest to me that would be a good model to follow? What are your thoughts about research contests? Yes, question in the middle here. Comment in the middle. Thank you for waiting for the mic.
There are two. Well, I'm part of the artificial intelligence and games community, and so we have the IEEE Computational Intelligence and Games SIG conference has had competitions on different games like Pac-Man AI and Driving AI and so on. And I like those models because they're now fairly refined. And then recently, at the AI and Interactive Digital Entertainment AID conference that happens at Stanford, they have a StarCraft competition that has several different tracks of sort of StarCraft AI, all the way from complete gameplay to micromanagement and macro management and so on. So it's so developers can get into sort of very specific parts of StarCraft AI, but can also go for like a general plague against each other kind of competition. So maybe those two conferences would be good models.
Can I ask you a follow-up question?
Yes.
What does it work for that community that that contest model helps the field progress forward? Has it been going for a number of years and people like entering those competitions? Or is it more of an entertainment, more of a distraction?
Well, both. So it's starting to get to a point where, so if you look at the IEEE transactions on computational intelligence in games, there was a paper recently that sort of combined all of the entrants and different techniques that were used and sort of compared them and so on. For the StarCraft competition, the first one happened last year, so it's very new. And so the submissions weren't sort of technically interesting, but this year we've already seen that there are some really interesting approaches that people are applying. So it might take time, but eventually I think you would get some interesting results.
Thank you for your comment. There's a question right next to you, or a comment right next to you.
I don't think it has to be the only way to run a competition, but I think that some of the things we want to achieve really require multidisciplinary teams and maybe problem-driven research, because in a sense this is technology-driven. We've got this cool toy and we're technologists who like playing with it, and we've got a hammer, everything looks like a nail. But
I think that's a great point.
Maybe it would be good to have at least some substreams that specifically, well, I'd hate mandating things, but they somehow make it more natural to have multidisciplinary teams and to be problem-driven. So, I mean, we had a talk this morning about health. I'm not mandating an area, but there are many worthy things one could do, and I think it'd be really nice to see if that works well. I haven't seen it, so it's certainly not based on experience, but just a thought.
One of the things that worries me about healthcare is because it's so potentially important to the human beings involved in that. There's a real social aspect to it, a real social benefit to it, is that you have to be kind of really earnest in it, and I'd hate to kind of just tantalize people. It needs like an earnest effort for healthcare. One of the things that we've noticed and have got feedback already from the community at large, both in academia and beyond, is healthcare is perhaps the most creative and most dominant of interests in this technology. It's just really dramatic how many different healthcare interests there are. I hope that what that will show is that the healthcare sector, and that looks different depending on where you are in the world. In the US, the healthcare sector looks somewhat different from where I originate from, for example, in Britain. So I can imagine that there'll be commercial healthcare interests, there'll be more government-funded healthcare interests that will explore this technology and experiment with it. I do get it that a contest in that area would be intriguing, and maybe to generate funding from governments to get applied research money for that might be a good way to generate some showcase applications in healthcare. Okay, thank you. Yeah, comment back there.
You probably have already concluded this, but just like students, in addition to bragging rights, would like cash prizes. Researchers, since this is a research project, would obviously want to have, other than bragging rights, to have it like a paper generated. So obviously working on this competition around a conference, like the previous speaker said, is eminently doable from a research perspective. So that we have things like proceedings and so on.
Are your grad students motivated by cash prizes?
No, I'm saying they're not. So I'm saying undergraduate students like Imagine Cup and so on would want cash prizes, but grad students would want something more documentable. So
at the Imagine Cup, one of the things that we are endeavoring to do, and I've seen other companies do this too, is vector the undergraduate programming contest more to an entrepreneurial style of achievement, and therefore prizes which involve a sort of venture capital advice, funding, industrialization, commercialization, counseling, and investment even is one of the ways that seems to be a model that's emerging as common today. Thank you for your comment. Any other comments about contests? So did you have a follow-up? I'm sorry.
Just said, so we probably want to set up program committees or something like that, some sort of
I'm sorry, I missed that.
So we probably want to have some structure in terms of committees or program committees or something like that for the conference.
You're volunteering?
Sure.
Say that man's name. Okay. Any other comments on the contest? Yes, yes, please. There's a lady here. Again, thank you for waiting for the mic.
Thank you. I do environmental work in remote communities far away, and I'm wondering if there could be a contest where there could be outreach to more remote communities, because I think this has a lot of applications for remote communities. So somehow to plug into either universities or organizations that could reach out.
I like your comment. I worry on that about the fact that the device today that you see up there, being such shiny black plastic and for a sort of a domestic living room environment, whether it's really robust for the sorts of environments that you might be thinking of. Would I be on the right lines with that? I mean, could it be a challenging environment?
I think if it was in the right context.
Right.
So if it was at a university, I don't mean bringing it out to villages.
Okay.
But the technology is really applicable.
So for the audio, I'll just reflect that back. So you acknowledge that there might be some challenges, but in the right context, the current device could find use, and therefore it would be worthwhile pursuing that dialogue already. Okay, I thank you. Thank you. Good comment. Yes, number 4.
I think you might want to have a look at some of the competitions that are out there already. So for instance, in the Rubber Cup competition that was held recently in Istanbul, there were a lot of teams using the Kinect technology in the urban search and rescue competition.
Cool.
And in also the domestic robots, robotics at home competition.
Thank you for
so
that.
So you might
highlight.
want to see what they're doing in those sorts of competitions to get a feel for what challenges there are. So
again, those of you that know me in a robotics context know how delinquent I've been in recent years, because I've been doing Kinect SDK and other NUI stuff. not attending things like RoboCup to see where things are at with the use of Kinect technology today. So it's a great point. I do recognise that, and it's mentioned in the Wired article as their opening statement, that the attraction of Kinect alone for the robotics community has just been quite remarkable. And as a closet and very bad roboticist, I am sorely aware of that fact, and I'd love to pursue it. So thank you for that highlight. There was a comment or question at the back, number 3.
There's always a balance between mandating a topic area or insisting that the people who are going to code it also have to come up with the idea. So just inspired by looking at Be Part of the Movement and the fact that we heard this morning about the social aspects of Kinects and of the Xbox and those sorts of technologies. The other question is there any matchmaking you could do in the sense of having people propose things? I've seen Kinect, wouldn't it be cool in my field if such and such might happen? And then to have teams of people who pick and code those up. That way you don't mandate, so there's a community aspect to putting up ideas. If only in my field you could do this, surely vision, surely audio, all the things you've talked about, they might play a role. And then people could actually pick those, and so you'll decouple those, but without mandating.
I think that's a really great comment. We've seen that emerge as a challenge already, that the lack of a matchmaker, and if we don't do that, then I really hope that those in the community that are interested in that will fill the vacuum, because there is a real opportunity for that today. I get it, and I can see how we could play that role.
Well, I guess the point was to run your competition in that way, so that you acted as the broker, and you put up people who would want things done and people who are coding, and then the competition is based on matching those together, and the winning entry is the best in those areas.
That's a really great comment. Thank you. So I think I'll just start to wrap up, but look for any other more general questions. What I hope you've seen today is some of our motivation, some of the backstory about why we've done this. I hope I've given you a taste about what's in the SDK. I'm going to be available extensively this evening. I hope to get some support, but otherwise it'll just be me talking more offline to you that want to follow up about the SDK and learn a little bit more about our thinking at the Demo Fest, starting at 4:30 and running till 7:30. I'm happy here in the last few minutes to stick around, that those that want to ask more general questions about the SDK, any more details that you haven't heard, bearing in mind that there will be a tutorial or two tomorrow, both an overview tutorial for 90 minutes and then a deep dive tutorial for a second 90 minutes. We really are trying to give you no escape from Kinect for this faculty summit. Everybody should be experts, or should be intrigued, or never want to hear about this technology ever again after this summit. So I'm going to be here a few more minutes if there are any further questions. Any further questions for the group? Yes. Number 4.
Following up on one of the earlier questions about other experts to bring into this field, one area that I certainly want to see more of are the linguists and anthropologists, because you are either explicitly or implicitly developing a new language of gestures, and a good question will be: do we create a library of these gestures? And if we do create a library, will it be standardized, and will it be a part of the package that you offer in the future? And that's where I think the anthropologists and the linguists have a lot to offer.
Okay. That's a great comment. Thank you. Yeah, question on the right here from Kenji.
Hi, I'm Kenji from the Cambridge lab. I work with Stuart and sort of dealing with Kinect in Europe. I think that's exactly the sort of question that Microsoft Research is looking at trying to get people to help us with. Certainly Andrew Fitzgibbon and the machine learning team in the lab, when we did the UK launch, his slide was a blank one and said, we don't care about the low-hanging fruit. We want to go after the high-hanging fruit. And what you've just described is one of those key fundamental questions about this new technology. So those deep questions about where this is taking us is exactly what MSR is interested in.
Yep, that's a great point. I agree. Thank you, Kenji. Thought I'd just put up some photos from the CodeCamp. So these are all developers from around the Puget Sound region, and I think we had a couple of stray Californians in there for somewhere. I think co-opted into the Pacific Northwest. But this was people at various stages of 24 hours sleep deprivation. Any other questions? So I think we should break then. Ready for the next session. Thank you very much for coming today. I really appreciate your time and your feedback. Some really great comments. We're really proud of the Kinect technology and proud to provide the SDK to you. Please show us what you can do with it. Thank you very much.